Hello there, this is Carl Freund with Cambrian-AI Research once again. And today I've got Fatih Parikli, Senior Director of Engineering at Qualcomm AI Research. And he's been working on some stuff that's pretty cool, something I think we can all relate to, which is 3D perception. Cameras only have, well, they have multiple lenses, but they don't produce stereoscopic vision. It's difficult to get a 3D representation of the objects you see through the camera. So Fatih's been working on some techniques that will address that. Welcome, Fatih.
Thank you so much, Carl, for having me. It's a pleasure. Yes, I'm all yours.
All right. Well, I'm glad you were able to join us today. It's a topic I was very interested in. I just published an article on Forbes and a research paper on Cambrian-AI.com. So if the listeners would like to go check those out, get more information in detail. But as an introduction, we asked Fatih to come on and just explain what the problem is. What things can be enabled that are not really possible without 3D perception? Why don't we start there, Fatih? What things could become possible as you realize 3D perception in mobile devices?
Very good. Many things. I mean, maybe I should go into more technical details. As living organisms, we actually perceive as humans and many other organisms, we perceive a world in 3D. So we need 3D to know how things are arranged in around us, right? How to move, how to take actions. This is 3D is fundamental to make decisions, move in the space, and same applies to the solutions that we are running on device. These AI-based solutions, taking this visual information and creating some value for such many applications. And there's a long list of applications. 3D applies to, for instance, XR, augmented reality, and virtual reality applications. There are many use cases there, and let me kind of high level mention applications that would highlight why we need 3D. Then I will give some examples for each application, how 3D is used. So XR is one of them. Autonomous driving, self-driving is another one. Robotic is a very big area, and that's also another very important area application. Camera quality. When we take the pictures, actually we can do better things. We can acquire higher quality videos and images by using leveraging on 3D. And of course, 3D directly helps to access control and surveillance, biomedical and biological images, data analysis, visual commerce, and inventory, main inspection, large space monitoring, and there is a long list of applications. Going back to to XR case, in XR we like to interact with the scene. Imagine that you have a kind of, let's say, VR eyeglasses, and you don't, it's opaque, you don't see your hands, but you want to interact with the scene, right? You don't want to hit things, at least, like there are lots of videos, funny videos, people fall down or hit their screens. So because they don't see the environment, when it is opaque, occluded, you don't know how, where is the room, how things are moving in the environment, other people, the objects. So by computing 3D and projecting in the right way, then we know where is the wall, so we wouldn't hit. Where are our hands, so we can actually interact with the scene. But this is just one application. We can put things, virtual things, correctly. Let's say it's an augmented reality application on the top of the, let's say, tables, and those avatars, we can play games. We know the ground plane, so we know the walls. We can project, kind of virtual information, videos. So there is a lot of application use cases for XR, for autonomous driving. Actually, without 3D information, such vehicles cannot move in the scene, and we don't want to hit anything, right? These are like big things. They will hurt you, kind of, if they.
That's kind of rule one on autonomous driving, right? Absolutely. Don't run into shit.
Absolutely. So you want to know exactly the 3D location, not to the 3D location of the vehicle in the world. And also you want to know where are the other vehicles, where are the pedestrians, whether their trajectories will intersect the, kind of ego vehicle. If you like to change the lane, how, first of all, you want to know where is the lane. And if you want to change the lane, you want to make sure there isn't any a vehicle in your blind spot in 3D space. So all decisions are made in 3D. That's why it is very important, almost crucial, essential, having 3D information for autonomous vehicles. Same goes correct for robotic applications. Let's say there's a warehouse and there are autonomous robots moving around. They are kind of grasping, picking things, objects, putting them into bins and carrying them. They need to know where those boxes, objects, products are, so they can correctly grasp them and put it into corresponding place. And they are autonomous vehicles. They don't want to hit each other. They not need to know their 3D locations. And when I say robotics, it's not only ground robots, aerial drones also. Uh, all the decisions are made in 3D because they move in 3D. Vehicles maybe in 2D, we can imagine on the road, but kind of in aerial aerial robotics, this is even more important. And if we know the depth of the scene, we can do bokeh effects, and if we know the depth, we can detect the objects better and then maybe get higher quality pictures on the important objects. So kind of there, when you capture the, kind of these important times, your memoirs, your pictures, or any content would look much nicer, less noisy, higher quality. That's important because sometimes we have only chance to get one shot, right? And we want to get the best picture. So 3D is there to improve it. And kind of, let's say you want to buy something and you want to try before really putting it on, like in eyeglasses or a dress. If 3D enables those type of interactions, so you will get a better idea how those things will look on you and in your environment. Also, you can maybe see the object on your desk and in your place. Let's say you want to buy a carpet, you would see in your room the carpet on the floor, kind of those type of things. There are absolutely necessary use cases for 3D. Why it is important to more kind of enablers, the things that I mentioned about visual commerce, for instance.
Yeah. So many people when they use their smartphones today, they think they have some level of 3D. You see 3D bounding boxes. You push the 3D effects button on Facebook, and it gives you kind of a 3D kind of a look around. What are the limitations of today's 3D technology and mobile devices? And give me like 2 or 3 things that Qualcomm AI Research is doing to take that to the next level.
Absolutely. On mobile devices, okay, it goes to the question of how we acquire 3D, right? There are basically 2 ways doing that, Carl. One is active sensing. Literally, a mobile phone is illuminating the environment, maybe using some IR light. We don't see it, but the camera will see it, and projecting something like is a random pattern or some lines, or sending these rays and then looking at the arrival times of it, like time of flight type of sensors. So this is one way to acquire 3D model of the environment. The other way of just collecting either single image or multiple images, like stereo, like we do, like we have left and right eye, right? So maybe using multiple cameras or video, getting these images and then creating a 3D model. For the first case, active one, the second one would have been passive because there is no illumination. For the first one, it's good because we don't depend on the environmental lighting, but since we are illuminating the scene, it is very power intensive. We would drain our battery on the mobile device, on the, let's say, mobile phone very quickly, and also their resolution is not that high, and there are many problems also. whenever light doesn't shine back for black surfaces, or if it is wet or specular, I mean the shiny surfaces. So such sensors, active sensors, doesn't see. For the image-based solutions, of course, it is more AI-based, and we train these algorithms using some data sets, and depending on the data sets, indoors or outdoors, the solution would be limited into the data set that we train. But we have, of course, many different scenarios. For scenarios, we have many models, so we can cover everything. So power, I think, is the biggest challenge, not draining the battery. And when we get the images, we have to do additional computations, kind of take the images, and then algorithm, the AI solution, learns how to look into local pattern and the global, what it sees in the image, to make an estimation decision. Okay, based on what I learned before, using the training data, what would be the depth of this pixel, let's say, in the image? So it will create a 3D model. Then we can collect these 3D models for each image and create a better model. We can combine everything to reconstruct a 3D model of an object. You can, like a 3D scanner, in a way.
Mm-hmm. Interesting. So in the paper, we discussed a couple of techniques that you're using, things like pose estimation and other things that I thought were pretty interesting. You want to talk about a couple of those?
Absolutely. We talk about how we would estimate 3D using only a single image, and then we extended it to, okay, can you do it? And these are AI-based solutions. And the first one was supervised training. Here is the input image, here is the corresponding depth, and how we will train the algorithm. The second one was using just a single image. That's kind of very challenging, and without any depth ground truth, any training data, just self-supervisedly, can we train a network which can then estimate 3D? That's what we also talk about. Then, okay, it was for single image. We also made it much more efficient on Qualcomm platforms, because Qualcomm platforms have very kind of nice features that would make running such AI models. They are neural network models, very efficient, power efficient, and also accurate. So how we will take this solution, neural network, and kind of transfer it onto a Qualcomm platform, like Snapdragon, MSPs. So it would run very efficiently and highly accurate. And then we switch into using two images, kind of like organisms, living beings can, and it would be more accurate because now we can use geometry. And then we talk about, okay, we do depth estimation from single image or multiple images. What else can we do? We show that we can estimate the pose of the camera. I mean, the sensor platform. We can estimate the pose of the other objects in the scene. We can estimate the pose of the hands. For instance, maybe now you are seeing my hand. The kind of our solution, our networks will find the key points of the hands, like articulated points, kind of in 3D, and you can do many other things, animations, editing, but that also applies to finding the pose of the human body. Then we talk about detecting things in 3D data. That 3D could be coming from a computer, like from image base or LiDAR sensor. For autonomous vehicles, there is a sensor kind of collecting this information, 3D point cloud, and then can we detect other vehicles, traffic signs, anything in the environment in that data efficiently. Because at the end of the day, everything has to run efficiently in a power conservative manner, but also very fast. I mean, it has to run real time, right? If you are driving or if you are interacting with the scene. So kind of accuracy and efficiency there is a trade-off. And I think we did our best to and provided the world's kind of state-of-the-art solutions to run it both efficiently and in the real time. And then we showed, if you take a single image, what else you can know about the scene. Can you know the materials of the surfaces, whether it's wood or leather or cloth or plastic or metal? Do you know the directions of the surface normals? Do you know the lighting? Where is the lighting in the environment? Even though you don't see the lighting in the image, it could be behind me. Like there's a actually you don't see it, but there's a light in front of me. So by taking a picture, can we say that there's a light in front of me? Why we want to do that? Maybe I want to change light from, let's say, bluish, yellowish to, kind of greenish. I want to change the object properties. Oh, by the way, we detect all the objects, including, like chairs, tables, like thousands and thousands of objects in 3D data and 2D data in the scene. So these
Wow.
are things we talk in the paper, yeah, in the blog.
So a lot of the things we talked about in the paper, they're all being researched. They're not yet products.
Oh,
But you also talked about, and I don't know, we don't want to get into product schedules. You're not a product guy. But you also talked a little bit about the things that are kind of the next wave of research that you have an eye on as you kind of wrap up the work you're doing in these 5 areas. Can you give us a couple examples of what the next frontier holds?
yeah, absolutely. There are things that we are very excited that they will coming soon. Uh, um, some of the things that I mentioned, they were published before, either this year, previous year, and they are already pushed to our, let's say, SDKs, product offerings, including depth estimation models and hand pose estimation, pose estimation models, object detection models. Some of them, of course, are maybe available to OEMs, like autonomous driving use case is something like that, because it requires point cloud lidar and very, kind of engineered system, overall system, but they are available. And some of the, let's say, XR-related depth estimation models, they are already in Snapdragon spaces or will come to Snapdragon spaces very soon. Um, and looking future, kind of coming soon, we will be providing very soon. I mean, not like in 2 years, maybe much sooner than that. Models that on your phone you can Qualcomm solutions, you can scan objects, in real time and create very accurate models of, let's say, a glass mug, which is very difficult actually to create because of the transparency, or a shiny mug or any object, kind of that is something we are leveraging on neural radiance fields, and people may know it as NERF. And they are maybe more than 200 nerve-related scientific publications already within the last year or so, kind of it's a very highly active area, and Qualcomm is very active also. Then other things coming soon, you may imagine that you are in front of your camera and there's a robot and you are training robot by just providing examples. You do, for instance, you are making an omelette, or cooking something, and robot camera just observes you, and then it imitates. So this is, we, in a way, that called in the scientific computer visions ML circles as 3D imitation learning. So such solutions will also come to our products. We are doing a SLAM, which is simultaneous localization and mapping, and which means that you just move or your hand phone or your device, your robot, your vehicle in the space, then it will automatically tell you, okay, where it is in the space, and create a 3D map of it. So kind of we are developing neural networks for that purpose. And kind of not everything we do is about visual data. Actually, we are very excited, and we showed such demos in the previous big conferences. we can locate people, Carl, in 3D space, and we can track them just using Wi-Fi or 5G. You know, kind of, you don't need a camera. You assume that you are in your home, you are moving between the rooms, and the system will know how many people are in the space and where are they, which rooms they are, and also their location in the space. And this is, you don't need to train this solution, even though it's an AI-based solution. It's very intuitive, very natural. So such offerings will come. It's not available yet externally, but I can say that in addition to, let's say, depth models, pose models, everything that I mentioned before, for visual data, such solutions for RF sensing will also an area we are very strong and big, and you will be amazed, and this is free, because you may have already one or multiple access points in your home. Now this is just additional feature supported by the Qualcomm solution. Yeah.
Wow, fascinating, just fascinating. You have a fun job.
Oh, that's why I'm at Qualcomm,
Yeah. Well, it's a pleasure to talk with you. Thanks for helping us understand the world of 3D perception from 2D devices using AI. We'll be anxiously watching the space and anxious to buy smartphones that have these capabilities and software that runs on them in the near future. So, Fatih, thank you so much for your time today. It's been a pleasure. We'll talk to you soon.
Yeah, my pleasure. Thank you so much, Carl. Yeah.
Stay well.
Yeah. Bye-bye.
Bye-bye.